This is Bioelectricity. I'm Roger Koch Barr. We're in Week 3, Segment 12, and we're looking at Week 3 in review. This has been a busy week, so let's take it step by step. First, we saw that a simulation of passive tissue produces a VM change that goes up, and then it decays back to the baseline. We saw that in contrast, a simulation of active tissue produces a VM change similar to the passive one during the stimulus, but then a huge change after the stimulus is over. We can name that change by calling it action potential, but actually we had no idea of what made it go. Searching for clues, we examined the records of channel measurements. We saw that people isolated individual channels by making use of the art of glass blowing, getting a very small, very narrowed down pipette, pulling out an individual channel. Amazingly, these channels seem to open and close randomly, but their statistics are not the same depending on the membrane voltage. In particular, the steady state number that's open may be predictable, not for an individual channel, but on the average. What can I say? What a week! When you look over at your arm and your hand, look at your hand and wiggle it. If you could see in fine enough detail when you looked at your hand wiggling, you would see millions and millions of channels opening and closing and opening and closing, a huge galaxy of channels, all operating all the time, opening, closing, randomly. It's just remarkable. So next week, our challenge is to make some order and sense out of all of this. We've said it, but we haven't really put it together. The good news is it can be put together, and we'll do it next week. See you then.